1, 2, 1, 2. You know, got some of them pistachios up in the building. Pistachios are an absolutely overpowered snack. Alright, let's just wait for the stream to kind of kick off and get going. Let's take the back off this. What is going on? Just me and Amir. How's it going, my friends? Random time for... Oh, I swear, the camera keeps doing this. All the time, don't know why. How's it going, guys? How's it going, guys? Good to see you here. Yeah, slightly earlier stream than normal. 8:28 here in Tennessee. Nice, not too bad of a time. H9, okay. All right, so on the bench today we have to start with an Edge EDX 800.4. These are usually very simple repairs. Just usually the output drive circuit has a diode that comes detached from the board as a result of dodgy glue here. So let's just wiggle this diode and see whether that's the case on this one. Yep, that's wiggling. So that's the issue on this one, as always. I don't know if you can see that there, but this diode is loose right here. And it's due to that glue kind of corrodes the solder there. Really frustrating. And I'm also going to be looking at a baseface DB 1.3 and also a band 4 channel that I've had for about 6 years now. Just kind of like on the parts bench, just in the loft as a spare amp. I'm going to see if I can put it back together and get it working again, just so that I can either use it or sell it. But yeah, how's it all been for you guys? Last couple of weeks, all been good? Anything of note that you want to talk about? Anything interesting going on over with you guys? Yeah, see that is completely loose now. This diode is completely loose, so I need to resolder that. Hopefully that hasn't killed any of the output MOSFETs. Now, I've got a new thermal imaging camera. So guys, check this out. Previously, I've been using this as my thermal camera. Check this out. Absolutely old ass ancient piece of crap from Amazon. Very cheap. Just a kind of random no brand K-Moon branded thing. And it looks like, well, you'll be able to see the image just kind of looks like this. It just looks like a massive blob. You see? And it's very low resolution. Big massive blob, very low frame rate, very hard to actually see what's going on. If I spread my fingers, right, my fingers are spread out. You see, it's very difficult to actually make out my individual fingers, let alone individual electronic components. So when I use this to see whether anything is getting hot, I'm generally just kind of like scanning over the board and just kind of having a quick look to see whether there's any red spots, but I can't make out what component is getting hot from just this alone. Look at the absolute state of that. Like, that's my hand, and you can't make out each individual finger or anything like that. It is rubbish. The resolution is so poor. So now we need to have a look at my new thermal camera. Look at this! Look at this thing! It is so high resolution, and it is such a quick frame rate. It is absolutely incredible. So we're going to be using this for all of our thermal adventures, and it's going to massively help with repairs and diagnosis and design flaws and all sorts of stuff. So that's going to be really exciting. And also, it just so happens I can plug it in via OBS, so you can get a really good image of it up here on the screen. So how cool is that? How freaking cool is that? So let's just get this diode resoldered on this board, and then we can check the output MOSFETs to see if they've survived or not. Finally got my sundowns on my base phase 5K fix. It's working great on them now. Oh, nice. I can't actually remember what that was. Base phase 5K, team 5K. Nice. I'm glad it's working. How long ago did I fix that? I don't recognize you by your YouTube username. I need to actually put the make and model of this thermal imaging camera in the stream somewhere, because they gave me it for free. So I didn't pay for this thermal imaging camera. I was given it for free to test out, and I actually really like it. And they've given me a discount code. So, oh no, there's someone at my front door. So you have to just bear with me a minute here, guys. Just bear with me a minute here, guys. I'll have to take the hat cam off and everything. Right, hang on a minute. Let's just put that there. Alright, sorry about that. Let's get the hat cam back on. What's going on? What's going on, Neko? How's it going? It was vibration damage mic. I can't really remember. Honestly, I've so much has happened recently, and I just can't remember any things that I've done really. So I'll give you the make and model of this thermal imaging camera in due course, but just for the meantime, I want to get it up on the stream so that it's up on the stream for everyone to see. So I'll let you know. I'll let you guys know in a bit. But I'm super impressed with it. I'm really happy with how it looks. It's going to be a massive help in the workshop. It's going to be a game changer for lots of reasons. Let's just shove Allen key in there. There we go. Right, yeah, anyway, what was I doing? Here we go. So just need to refresh these solder connections on this diode that you can't really see because it's underneath this inductor, so you just have to bear with me while I do this for a minute, and then we can check the output FETs. So these all fail from this exact problem. From the factory, they use a glue that seems to corrode the lead-free solder that they use, and there's always a diode here that gets covered in glue from this inductor, and it just corrodes the solder joint and lifts the diode. And sometimes it kills the output MOSFETs and sometimes it doesn't, so let's have a look, see whether it has or not. Turn the multimeter on. So the FETs which are for this channel that it always happens on are over here. So we have no short there. Ah, no short there. I do believe we have got lucky in this instance. Let's just check there's no other dead FETs. There shouldn't be unless there was some other issue. That is a rectifier, so that's fine. Yeah, cool, this is going to be a nice easy fix. Just need to resolder the diode and that's probably going to be good to go. Lovely jubbly. You can just call me, so the reason I haven't been calling you that is because that looks harder to pronounce. I-R-I-L-I-A. Irilia. Irilia? Is that right? Irilia. Nice. I'll call you that from now on. Look at the so this is the heat gun. Check this out. You can see it heating up my hand. And you can maybe also see it heating up the board. Yeah, very cool. The only problem with it is that I do need to keep changing it between modes. I need to keep changing it from 150 degrees Celsius as its maximum to a higher temperature mode. This is now up to 550 Celsius because otherwise you can damage the thermal thing. It does have auto range on the Android app, but not on the Windows app for some reason, which is a bit annoying because that's why I'm going to be using it on Windows with OBS for these streams and stuff. So if I grab this now and show you close up, so that's still 150 degrees Celsius. If I change modes, it improves the clarity a little bit. So yeah, so this is now on the lower temperature mode. So yeah, we're still at 100 degrees, so I'm just going to let that cool down a bit. And we also have a macro lens for it, which allows us to get up really, really, really close. Look how close we can get. I can get right up to these components, and we'll see them get hot in a minute when we power it up. It's super cool. Hey Sam, I have a Sundown SFA 2000D. Whenever I connect the ground and the terminal, the output drain and gate close and put the amp in protect. Wait, hang on a minute. Whenever I connect the ground and the B plus, the output drain and gate close and put the amp in to protect. It shouldn't make any difference. That putting 12 volts to the power terminals shouldn't affect the output MOSFET gates at all. That's very strange. That sounds like a very unusual failure I'd have to look at on the bench myself to understand what's going on there. Look how clear that is. Incredible. Right, so we've cooled down enough now, I think. So let's go ahead and power this up, and hopefully that was the only issue. I have a Taramps Big Boss 3 bass that works but clips super early, doesn't go into protect or anything. What could it be? It's unlikely to clip early. The clip lights in those are very accurate, so it might not be clipping early. You might just be asking too much from it, or your impedance rise might be too high. What are you wired to? Are you wired to 1 ohm, 2 ohm, 0.5 ohm? Let me know. It also could be that your low pass filter is way too high. So first of all, make sure that your low pass filter is set to around 40 to 50 Hertz. You don't want any higher than that. So make sure you have a low pass filter set on the amplifier or on your head unit or both. You don't want your low pass filter set to 80 Hertz or anything ridiculous like that. So check your low pass filter settings first, because having a low pass filter set too high will cause the clipping light to flash on the beat way too early. So we still have a lot of heat over there where we did some soldering. But let's power it up and see whether that was the only issue. It's going to 20 volts per division on the scope, and 5 microseconds, reject low frequency, and let's just check where our low side drain is. That's a bit concerning. I'm going over all of the output FETs, and we seem to have low voltage on. Why have we got negative rail on the what? We've got negative. Hang on a minute. All right, there's positive rail. Right, positive. Yeah, we've got a bit of negative rail coming through on the drain there of the low side, which is not what you want to see. Okay, I've seen the issue. Another common problem that you get with these amplifiers is that the little 47 ohm resistor, which is over here. Okay, over here there's a 47 ohm resistor by the rail caps, and that connects between the output side ground and the main side ground, and it's really common for that to just blow open when there's output section faults or when the user accidentally touches something on where it shouldn't touch. So let's just check the resistance of that. Yeah, it's through the sky, so that needs changing, and then that will probably sort out the weird voltage readings we're getting on the output side. What I usually do in this case is I replace this resistor with a large through-hole resistor that's just a bit more beefy and prevents it from blowing so easily when the user makes a quick mistake. I was told the negative speaker cable touched metal while on, which caused a spark. And did the issue only start presenting itself after you did that? In which case there could be something damaged, but it's very unusual for the amplifier to come on and play while having a fault. Usually they'll just go straight into protect. So okay, well yeah, there's definitely a problem there then that needs looking at. I wouldn't be able to say what though, but it could be that one half of the amplifier is not operational in terms of Class D switching, but the other side is. But usually that would cause the amp to go into protect, so it's quite unusual that it hasn't. I'm just seeing some what looks like condensation corrosion over here as well by the MCU. I don't know if you can see that little puddle there of like junk. I'm just going to get rid of that. Yeah, so I would say that amplifier needs proper investigation with an oscilloscope to confirm what's going on with the output section there. So let's grab a new 47, and like I say, I'm going to replace this with a large through-hole component that is a bit more resilient to, you know, quick user mistakes and isn't going to just blow open straight away. These days we see class TD. So class TD doesn't see, it's not an official amplifier topology. It will likely be a marketing term. I'm not, familiar with that term specifically in how they are claiming it operates any differently. You had like people were using class T or class TD for tripath amplifiers a long time ago with like the Phoenix Gold Tantrum, I think it was. And a few others that use the tripath class D modules. Very high switching frequency that was variable with the frequency it was playing. So that should have sorted out that weird issue we were getting with a bit of stray voltage on the output FETs. Let's turn the power supply back on and have a look. So we should have positive rail there we go, and negative rail shouldn't have anything on it. No, that's good. Okay, excellent. So now we are safe to power up fully and just check that we have class D switching on all of these. Yeah, there we go. 2.6 amps idle current draw. Let's just make sure that that is present everywhere. Got that one there, that channel, and that channel, and that channel, and that channel. Excellent, yeah, that's looking good. How does that look through the thermal imager though? Just out of interest. Be really interesting to see. So we're going to put the macro lens on so we can get up real close. We're going to have a look at the drive circuit as we power it up, and you'll probably see the drive circuit suddenly come to life and get kind of warm here. So let's go really close. Here's the drive circuit. I don't know why it's kind of glitching around a lot. It wasn't doing that a minute ago. There we go, you can see the temperature on some of these resistors, 37 degrees Celsius. And you can see the temperature of the 2092 drive ICs. Actually the resistor, the 10 ohm resistor that feeds them is actually getting hotter than the chip itself. 41 degrees Celsius on the 10 ohm resistor that feeds VCC to these chips. This is super interesting. Look, I'm going to power the amplifier off, and you can see the heat gradually dissipate. Then power the amplifier back on and you'll see that sharpen up. See that heat suddenly come in. Very cool. Very cool indeed. Do the gate resistors get hot? Oh yeah, look, you can see how hot the gate resistors get. We've got 49 Celsius, 50 degrees Celsius through the gate resistors. So they're definitely doing some work. That's very interesting. It's really cool to see this so close. Isn't the temperature clocked according to the height or distance of the focus? No, not in this case. It's just using the infrared energy, a bit like how a normal camera looks at light. And it can get it accurately from a distance. Any heating on any of the power supply gates? No, see the power supply gates are like stone cold. It's just the output gates that are kind of toasty. Super interesting to see this. Any components in the filter network getting hot over here? Let's have a look. Now we've just got the gate resistors. Filter network's nice and cool. The output inductors don't get hot under idle operation. Got some components here for the auxiliary supply rails getting a bit warm. That's fine. Yeah, that's really cool to see. Love it. I love being able to see that. That is excellent information. Very cool. But yeah, that's working just fine. So that was just needing a new diode. Replaced diode resoldering in the output side, as these always do. Alright, so let's put the back on this one, and let's have a look at the next amp we've got on the bench today. Class TD amplifier is a hybrid design that combines the analog characteristics of Class AB with the efficiency of Class D. Yes, but I need to know exactly what the operational differences are. So I understand like that those are like end user terms. Those are not terms that describe the actual operation of the circuit. So we need to know exactly what Class TD is doing on a circuit level. It's similar to Class H. Okay, so Class H will vary the rail voltage depending on the amplitude of the output sine wave. Which means that it generates less heat at lower amplitudes and are idle, but then the higher rails are present when they're needed, when the sine wave goes that high. So basically, yeah, it just prevents the amplifier from just always running with really high rails and therefore causing a lot of heat and energy loss at the bias point between the transistors when it's not necessarily needed as per the audio signal. So yeah, it'd be interesting to see what TD are doing differently there. Damn, this is a baseface DB 1.3 that has never been opened before. That is very uncommon. These usually are always getting repaired, but the warranty sticker is intact on this. Oh no, wait, never mind. Ignore me, the warranty sticker isn't actually over the screw, so yeah, this does look like it's been opened and repaired before. Most of these have now, they're rubbish. Can I draw something on this? Draw a smiley face. Not quite got the, there's a bit too much thermal mass on this to do that. Hello Robert, how's it going my friend? Can you Google it please? I'll have a look in a bit. Yeah, I just want to have a look at this first. Right, let me Let me give you the name of this thermal imaging camera because it's freaking awesome. It's so sick. Just bear with me a sec. So, thermal. Right, this is a Thermal Master. P2 Pro Plus. All right. So let me just add a bit of text on here. Thermal text. Thermal Master P2 Pro Plus. Link to buy in description. Which I shall put there. And then I also need to make a hotkey so that disappears and appears when I do that. So settings, hotkeys, thermal. Show thermal text and hide thermal text. Excellent, there we go. There we go, that now appears and disappears. Right, let's have a look inside. So we have the Baseface DB 1.3, which is a generic Chinese amplifier circuit design. Almost always we have dead output MOSFETs. Yo, what's going on, Sinewave? Good to see you here, bro. Yep, we've got dead output FETs. Always get dead output FETs on these, so let's remove it from the heatsink. Look, Sinewave, I've got the thermal imager on OBS. How sick does this look? So cool, man. How's it going, David? Is this a tool review? Nah. So this is this thermal imager I'm going to be using for years now on my streams. Like it's let me just show you the difference, right? This is not a tool review, okay? I haven't like been paid or anything. I was recommended this thermal imager by somebody, one of my viewers. Someone in the live chat said, "Oh, Sam, you need this thermal imager because the one I've been using has been this for years, and this now I realize is absolutely dreadful." Okay. Have a look at the difference between this, okay? So if I was wanting to look at something on the thermal imager before, here's my resolution before. Okay? It's just like a blob basically. Very hard to make out individual components. Barely make out my fingers there. And now compare that to this, like absolute night and day. It's like you've just jumped forward 20 years in technology. It's crazy. Straight up. Yeah, it might have been you that suggested I get one. So I was gonna buy one, but I thought, you know what, let me see if I can use my influence here. I reached out and I was like, yo, I'm thinking of getting one of these, but you know, if I get one, or if you want to send me one, if it's good, I'll be basically using it on every one of my streams for years. So, you know, feel free to send me one if you want to send me one. So they sent me one for free. So, but I actually do think it is insane. Like, I wouldn't be saying that if I didn't think it was sick. It is fucking awesome. So this repair shouldn't take too long, and once we've done with this, I'm going to be trying to get a Banda little 4-channel here. See this? I've had this Banda 4-channel for absolutely years. I gave up with it many years ago when I was first starting out in amplifier repair, but now I know a lot more about amplifier repair. I thought I'd give it another go, see if I can get it working. It's just uses 2092s, so it's very similar to everything else. Where have I mounted the thermal camera? Well, just for now, I've just literally mounted it on a bit of blue tack up on my bench here. You can see it's just kind of like hanging here, chilling. I'm going to 3D print like a more permanent mounting solution for it, but I want to be able to grab it and like bring it down to the board as well. So yeah, it needs to be not something that's too permanently fixed. But it's tiny. One more upgrade, small drill to undo the screws. Yeah, I could do. I don't want to get into the habit of using an electric screwdriver for the heatsink clamps though, because I don't want to get into the habit of using it for doing them up, because you need to do these things up by hand so you can feel the torque, because the heat sinks are really soft and you easily strip the threads and break the screws, and it's an absolute nightmare. So you want to be doing this by hand, and it's always a good idea to take them off by hand as well, just so you can feel how tightly they were done up. I do prefer doing this by hand. How did you connect it to PC, bro? So I got a USB-C female to USB-A adapter wire on Amazon. It was £6. I can send you the link. So yeah, it's USB-C female to USB-A 3.0 adapter. There's one on Amazon for £6 delivered. That's just what I used to connect it up. PC doesn't have USB-C. Nope, the motherboard does not have USB-C. I'm using an i5 what am I using? A 4690? No, hang on a minute. 74. Yeah, I think it's a 4690K. It's old. This is an old processor that I'm using, and the motherboard doesn't have USB-C, but does have USB 3.1 or 3.0 or whatever it is. Yeah, so for my main PC downstairs, I've got a 7800X3D. It's just a workshop PC. Like for this PC, live streaming like this isn't really that taxing on the hardware. Look, if I open up Task Manager real quick, let's have a look at Task Manager. So this is my current performance. So the CPU, it is being utilized a fair bit, but you know, we're up at like 55%. I have overclocked it, so we're at 4.5, it reads slightly lower. And we're using NVIDIA NVENC encoding for the rendering, so the GPU is being used. I've got a GTX 960, again pretty old, so for streaming purposes this works brilliantly. I don't need anything crazy in here. I'm not gaming, I'm not like doing crazy rendering. For live streaming this is perfectly enough. Yeah, I've got two PCs downstairs. I've got a 7800X3D with a RTX 3080, and then in a different rig downstairs I've got a 9600K i5 9600K overclocked to 5 GHz with a 1080 Ti, which is aging a bit now, but it still does the job. What's up, Henrik? How's it going, my friend? What have you missed? I don't think you missed too much so far, to be honest. So yeah, needs all new output MOSFETs, this bad boy. Before we remove all the FETs though, we could just see if the drive circuit survived by simply cutting out the dead FETs. Actually, you know what? I think there might only be like one dead one over this side or something. Let's have a look. Not that one, not that one, not that one. That one! That one's dead. Not that one. And that one. So we've got two dead MOSFETs. So let's just cut those out for a minute. And then power it up and just check to see whether the drive circuit has survived. Because if it hasn't, then, you know, it doesn't matter if we risk damaging the other MOSFETs in here, because we're going to change those anyway. So might as well do it while we're here. What do you think in future will be one IC which does audio processing to replace all the MOSFET driver? Yeah, that already exists. There's GaN FETs, GaN FET ICs that have basically the entire drive circuit and output MOSFETs inside one package. You just have to feed it with an analog audio signal and some supply voltages, and it just works. So that is already here, my friend. Already exists. Okay, so let's just power this up and see whether we get switching of the Class D type. Uh-oh, okay, we have drive circuit fault. As you can see here, I'm probing the low side drain, and as we try to power this up, we get a swing to negative rail. You know, slowly swing to negative rail, so that suggests that there's a driver that's bad. Now, with our new thermal imaging camera, helps if my camera isn't frozen. With my new thermal imaging camera, can we identify which driver is bad before we remove all of them? So let's just jump on here and have a look. So we are going to be looking at the drivers over here and the drivers over here. So I'm just going to power it up just a little bit at a time. We're just going to see if any of these drive transistors get kind of hot over here. Okay, so nothing over this side. How about over this side where there were some dead MOSFETs? Nope, so they don't get hot with rail, so no worries. We won't be able to identify it just with the thermal imager just there. So let's just wait for the rail voltage to sink down to ground. And then we can remove the drivers, remove all the rest of the FETs, and fit all new parts. How cool to see the thermal reflection. Yeah, that's very cool. Sam, you're using the micro lens. Not at the moment, I'm not. When I get really close, you have to. The macro lens is only useful when you're like about an inch away. Any further than an inch, and you're better just using the regular lens. I think this 2T, I think this is the dead one. Just going by the multimeter readings here. Sine Wave 02. Big Boss 5K has GW40H65 on the outputs. Really interesting. So they've changed from using the IRFB 4127s, which they were using for the Smart 5. Have you had any more shocks from the mains? Fortunately not. I have not. Henrik, yeah man, by all means send me a message on my BearVids Facebook page, we can have a look at that. One thing actually that I find annoying about this though is that with this thermal imager is that the Windows software doesn't have auto range. So the Android software, you can set it to automatically switch between high temperature mode, which goes up to 550 degrees Celsius, or low temperature mode, which is -20 to 150. With the Windows PC software, you have to manually select it. There's no option to have it automatically range, and that's a bit dodgy because you can actually damage the thermal imager by pointing it at a really high intensity thermal source, like my soldering iron here, for example. Currently chilling at what am I up at? 350 degrees Celsius there. So if I had the thermal imager set to its lower range, that could actually damage the sensor. Okay, that's the 2T transistor replaced. That's the one that I'm suspecting had some damage. So let's just wait for this to cool down. And now I've got the thermal imager. You know what? That's so cool. I can actually see how far I am away from it being a safe temperature to run and operate. 88 degrees, 85, 84. If I blow on it a little bit, see, you jump down to like 74, 70, 64. So you can spray isopropyl, but what you don't want to do is you don't want to cool the component down too quickly. If you spray isopropyl and cool it down too fast, it can actually cause stress damage inside on the die of the silicon. So you don't want it. You want it to cool down gradually with the rest of the PCB. Yeah, if we can probably safe to spray it now. Yeah, now we're down at like 40 degrees. That's good. Okay, so let's see whether we still get voltage leak as we try and power this up then. We're going to probe the low side drain and be interesting to see whether it was just that transistor or whether we need to replace all of them. Usually I replace all of them on these just because they're cheap and easy to replace anyway, might as well. Okay, so we still get voltage leakage there. So we've either got more drive circuit damage or one of the output MOSFETs is actually damaged. So rather than speculate and try and find the singular dead part, I'm just going to replace all the drivers and all the FETs. Might as well while we're here because we're going to be doing that anyway. So the link isn't in the description yet because I haven't actually put it there. Let me do that right now real quick. Let me put the link in the description. Oh man, why does my camera freeze all the time these days? I don't know whether it's the USB cable or what. Really frustrating. Right, I'm just quickly putting the link to the thermal imager in the description real quick because it is really freaking great. Just bear with me a sec. I've got to go edit my stream. Thermal Master P2 Pro Plus. 1 second, guys. This is a bit more complicated than I thought. Just 1 sec. Okay. Okay, there we go. It's in the description. Right. No, so the thermal camera, someone on my live chat recommended that I get this one because it was so good and very affordable. So I was almost about to buy one, but I thought, hang on, just before I buy it, I'm going to be using this in all my streams. So let me just reach out to them and see if they'll send me one for free, because obviously it'll be shown in all my streams. If it's good, then obviously I'll be like, yo, this is great. So they sent one to me for free. So I'm under no obligation to say that it's any good. It's a bit buggy still. Like the Windows app is a bit buggy, and could do some better features. The Android app is great though, and the performance of this thing is like mind blowing for how cheap it is. Like you'd be paying like £800 to £1,000, if not more, for something like this from the likes of, I don't know, what's the main brand of thermal imagers? Not Hako, can't remember off the top of my head now. But yeah, for like industry standard brands, you'd be paying thousands for this level of thermal quality, and it's like super cheap. So I do love it, and I will be recommending it because I think it's really cool. But yeah, oh, Fleur, that's right, Fleur. But yeah, no sponsor, but they did gift it for free. And if I like it, then I'll use it, which I am. There we go. That's all sorted. Right. Let's get these MOSFETs out. Hello, William. What's going on, my friend? Right, so I managed then to wangle myself a free thermal imaging camera. I've also reached out because while I was doing this, I was like, hey, I should technically be able to reach out to brands and like get free shit, right? With the kind of number of subscribers I have and stuff like that. So I also reached out to who makes oscilloscopes? Who did I reach out to for oscilloscopes? Oscilloscope. I reached out to Wriggle. I reached out to Wriggle to see whether they would do me a cheeky oscilloscope for free. That would be pretty sick. And I also would really benefit from a new soldering iron. So I feel like the soldering iron situation, I'd be able to get something really high performance, but from like a random brand from AliExpress or something like that. There's a lot of these Chinese soldering irons which are, you know, USB-C or like, you know, with little screens on them that are actually really good performing units. So maybe I can contact a few of these guys and see whether I can wangle myself some free crap that way. But the Wriggle free scopes and stuff potentially sounds like it might be a good one. I've no idea if they're any good. Again, nothing that I do here will be sponsored, so it's not like I'm not obliged to say whether anything is good or not. I would just be getting stuff for free to either use if I like it, or, you know, check out, show you guys. Have you seen the new Auto Connect DD1 equivalent? I have not. No, I haven't come across that yet. Wriggle oscilloscopes are really good. Good to know. What do you do with old parts when you remove them? Depends really. These IRF 640Ns are very cheap to buy, and I've got hundreds of them in stock. So I just throw these away because there's no reason for me to keep them for any reason. But more expensive parts, especially where they are pulled from like a bank of the amplifier that didn't have any damage, I'll usually keep them to one side as you know, salvaged used spares. Sometimes I can offer them to clients when they want a cheaper repair. Like if I quote a repair and they say, you know what, that's too expensive, and I can say, well, I can do a cheaper repair with some used parts, but obviously there's no warranty. So I keep them for things like that. I have Wriggle and what the heck? How do you pronounce that? Then it was USB powered. I modded it with an internal battery and charge controller, so it's portable. Nice. That's pretty cool. Yeah, you can't see the battery percentage. Yeah, that's a bit annoying. Yeah, it's a bit of an earlier stream today. I've got a bit of free time this afternoon, which I haven't had for a while, so just thought I would quickly jump on stream while I have the opportunity. It's a hybrid of Class AB and Class D, switching power supply with analog amplification. Well, that's just any Class AB amplifier with a switch mode power supply. That doesn't mean anything. Like every single car audio Class AB amplifier has a switching power supply. So does that mean that every single Class AB car amplifier is Class TD? We need specifics. I will have to Google it, but we need specific information about what exactly is different about these, about the actual amplifier side. If it's literally just a Class AB amplifier with a switch mode power supply, Yawn. That is nothing new, that's just marketing nonsense. Right, somebody in the chat, find me a schematic for a class TD amplifier, and we'll have a look and see whether it's actually a new class of amplifier or whether it's just a marketing gimmick, just a name for something that already exists and it's not really an amplifier class. Yo, what's going on, Matt? power supply has an intelligent feedback. Okay, so potentially similar to class H then, as somebody else said earlier. Now it depends if the power supply is adjusting the rail voltage as per the sine wave demand, the sine wave amplitude demand, or whether it's adjusting the amount of current that's available perhaps. What's up, Jarrett? How's it going, man? There's 4 2X's. And I just need one more 2T. There we go. Is it possible to change a subsonic filter which is limited to 18 Hz to 10 Hz? Yeah, you just need to change some capacitor values and maybe a resistor value, or yeah, resistor and capacitor values in the preamp circuit for the subsonic filter. Yeah, easily doable. That one, that 2T, needs really cooking because it has one of its pins connected to a ground trace that has pretty high thermal mass, so you've got to really kind of blast that one to get it to solder. But all the others, these 2X's, these are pretty low thermal mass parts, traces and stuff, so you haven't got to heat it anywhere near as much to get these to connect nicely. Alright, so that's all the drivers replaced. Now the last thing we need to do is to check the gate resistors. When you have dead FETs on these, gate resistors often blow. So every single electronic component, apart from the MCU, every single electronic component for any amplifier is just a generic electronic part. There are no electronic parts that are specifically made for any of these amplifiers. They're all just generic parts. Even the MCUs, they're a generic part but with custom firmware. But yeah, everything is just generic parts, so nothing is made specifically for any amplifier. Okay, all the gate resistors appear to be intact as well, so that's good. If you had money, etc., to have your own amplifier factory, how would you design your amps? Well, I'd just try and use the most modern semiconductor technology available, which at the moment I think is GaN-FET. So it'd all be GaN-FET amplifiers. I'd pour loads of research and R&D into making GaN-FET amplifiers, high power ones, very stable and very thermally stable as well, so you can absolutely wang on them for hours without them overheating. I'd have health check. I'd have them be able to detect the output speaker load and adjust themselves depending on what they were being driven into. There'd be lots of diagnostics like available on the amplifier on like a little screen to show all the rail voltages, the amount of power. I'd have like a little oscilloscope trace on the amplifier case as well, perhaps. There'd be all sorts of things I'd do. So one thing I've noticed about this thermal camera though is that after being on for a while, it kind of slows down like this. So if I stop and start it again, does that sort it out? It does, okay. So that's an issue I need to bring up with them. Okay, so this should be ready to go now then. We've just got to power it up and just check that there's no DC voltage leaking anywhere where it shouldn't be. Check that we have Class D switching, that looks nice. Alright, let's test this. Whoa! Huh? So I just heard like a little click sound, and then we had constant current, 3.6 amps, continuous. And that was during the power supply building the rail voltage. So what's happened there then? Do we have some of the power supply FETs that were weakened by this failure event on the output section, and have now, you know, one or more of them have decided to fail? If I remove my power wires, nope. So we've got no short on the power supply. So what the heck was that then? What was that all about? Possibly a bit of solder on here. That's not happened before. I'm usually quite good at brushing this off, but maybe there's a little bit of solder on there or something. Okay, no, so we still have current being drawn, but we have no short. Okay, well, let's use the thermal imager to see what's getting hot over here on the power supply side. Can't really see anything that's getting hot, to be honest. Drive transistors position wrong. No, my friend. No. We haven't even powered up the output section yet, my friend. This is literally just the power supply section building the rail voltage. It built about 7 volts worth of rail, and then we have a dead short across the amplifier power terminals, and the power supply section we haven't touched yet. So no, it is nothing to do with any of the work that we've just done, because the output section is not operational and we haven't even built rail voltage yet. So something funky has happened with the power supply. Usually this kind of behavior is a shorted power supply MOSFET, but with 2 amps constantly going into this board, I'm not seeing anything getting hot anywhere. You can see there's nothing getting hot over here on the output section, because the output section is not directly connected to the power supply side, because we have the transformers which are in the way. So it's nothing to do with any of the work that we've just done. This is like a new problem that's just appeared. Okay, it looks to me like we have a vibration damage fault. Look at this. If I bend the board like this way, the current draw goes away, and if I bend the board this way, we get current draw. Bend, 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 bend. So this is going to be a shorting transformer. So which one is it? All right, let's pull away the edges of these, because sometimes it's just these bits on the edge here. Ah, no, you know what it is? It's probably this. Look at this. There's 2 rails here. I don't think these should be touching. Look at that. I suspect that's 12 volts and that's ground. Yep. Pull those away from each other. It's probably just that. That's very, very surprising that that never happened while this was in the heatsink. I suspect that when this is in the heatsink, it was just bent just at the right angle where that didn't actually touch. That's crazy. Okay, so now, yeah, look, now we have no more current draw, no matter what we do. So yeah, it was just these 2 were touching, and we can confirm that by seeing we have 3 volts on that one and ground. So yeah, we have, this one was live and this one was ground. So yeah, that was why. And that was also why we couldn't see any heat on the thermal imaging camera, just because it was a very low resistance short through here. That's interesting. All right. So let's continue with our normal power up then of the output section here. There we go. There's full power up. We have 1.5, 1.4, 1.3. Yeah, very low idle current draw, which is nice. Output switching looks good. Yeah, the idle current draw is very, very nice indeed, so that's all good. That's looking very nice. Let's power that off, and let's have a look at that through the thermal imaging camera just for fun. See what gets hot on these and what doesn't. So output MOSFETs, do they get hot or not? Let's power it up again. Okay, so no heat on the output FETs on these boards at idle. The drive transistors, they run a little bit warm, but not too bad. Got the op amps in the preamplifier, they look fine. These resistors are the rail pull down resistors. They're obviously running slightly warm. Nothing on the output driver card really runs that hot. So yeah, nothing really runs hot at idle on these amps. So they're quite well spec'd really for their parts, you know, running at idle like this. Nothing's running super hot. Even the drivers, maximum we've got there is like 38 degrees Celsius, not too bad for a tiny component like that. Power supply driver side, let's have a look. No, pretty good. Power supply MOSFETs, it's all looking good as well. So yeah, these are a pretty well optimized board in terms of idling and stuff and component choices, but it doesn't mean to say that they're a good amplifier design. They're not. These are not a very good circuit design, but in terms of, you know, component choices, power, you know, the power ratings of each of the parts and how they're running, these have some of the lowest idle current for their power rating that I've ever seen. This is like a 2000 watt amplifier. It makes like 2k at 1 ohm and it draws 1 amp idle. So if you are planning a sort of portable system that runs on batteries, obviously you want the lowest idle current possible. This is not a bad option. This type of circuit design, not a bad option. Is the live chat working or is it dead? Oh, here we go. Did you get your hands on any GAN FETs? Not yet. I haven't purchased any myself just yet. But if I design an amplifier in the future, then I will be using GAN FETs for sure. I would recommend using a driver uninstaller like DDU to completely wipe any previous graphics drivers that may be installed in this Windows, then go to the NVIDIA website and download the latest drivers for the 3080. Full stop. Sounds like you are experiencing a blue screen, full stop. This can be caused by driver mismatch, if you had drivers installed for a different graphics card in the past, these may need to be fully wiped using a program like DDU, full stop. You can also download a program called Blue Screen View, which will give you all of the details about what exactly has caused the system to crash, full stop. A hardware level malfunction of a graphics card doesn't typically cause a blue screen, it will just cause a graphics driver crash or errors, full stop. If you can give me the stop code of the crash that you are experiencing, either when it happens or via Blue Screen View, then I can advise further. I sold a graphics card, a 3080 Founders Edition. So now I'm tech support for the guy who bought it, obviously. that's how it goes. There's nothing wrong with the card. I've been using it for ages, it's fine. So he's just having some issues installing it, and because I'm the seller, I'm going to get roped into trying to resolve his problem now, obviously, aren't I? Yeah, selling graphics cards is a massive pain in the ass, so I've been very specific about who I'm selling the cards to, making sure that they're genuine buyers, doing collection only rather than postage, covering my back basically on everything, testing the card fully before selling it. So I had some graphics cards that I was selling, and yeah, ran them for a while, tested it, etc., and it's all good. So hopefully he'll get whatever issue he's having sorted. Yes, put the old graphics card back in and then download Blue Screen View, so that you can analyze what it was unhappy about, full stop. Which model is the old graphics card out of interest, comma. If it is an AMD, then there may be some problems with driver mismatch going on, comma, in which case you will need to uninstall the graphics drivers prior to shutting down, comma, then swapping the card over. So I've actually got about 6 or 7 RTX 3080s for sale, and I've also got a 2070 Super and a 3070. No, they weren't mine. They were, a friend of mine was had like a sim racing rig business where he was like hiring out sim rigs and stuff. But yeah, he's not doing that anymore, and he wanted to sell off the cards, and he offered them to me in bulk for like really cheap. So I bought all of them, and I'm now selling them off separately to make some money. Yeah, I bet they have some great setups. Sim racing is awesome. I've had a play around with it a little bit myself. I've got a Pimax 8K X with my main rig. I've done some Assetto Corsa stuff. I haven't messed around with like direct drive wheels or anything. I've just got an old G27 with a H pattern, but even that is enough to convince yourself that you're in the car. One of my old Proton bucket seats I was using, and I mounted an old 8-inch subwoofer into the back of the seat to give me some tactile feedback of like the road bumps and stuff like that, and that was really convincing as well. It was really cool. Okay, cool. There we go. So that's 2 amplifiers down. Now, like I said, I want to look at this Bander 4-channel that I've had for a long time. Just want to see if I can get that up and running, because it's a pretty cool little amplifier when it works. It's a little Expert, I think it is, a little Expert 800.4, something like that. Any amps you like working on the most? Anything surface mount, to be honest. I really like working on surface mount stuff. I find it a lot quicker and easier. Amps I like working on. I quite like working on tar amps, to be honest, just because I know them really well. I know the circuit designs really well. Alright, so this is the Bander, what is this, 8.4D. Let's start from fresh with this, because I have no idea what the issue was. I think it was output section failure. Let's just start from the beginning with this and see what we can find in terms of problems. Let's get rid of that. Don't know why there's a little wire on here. Don't know what I was doing with that. So we've got a 4-channel that's using IRS2092 sort of cards here. Output MOSFETs are IRFB 4212s, which are not made anymore, but I think I do have some kicking around spare. So yeah, let's kind of start from the beginning and have a look. We've got an MCU on this board here for the power supply. And I have removed this card before, not really sure why. How's it going, RTS? Recently fixed a Sundown SFB 5K, and the customer took Taramps MD8000 to run it. He just left the Taramps here and said it was junk. Really? That's very strange. Can you do a quick check of the DLS Performance Slim PS 1.500? Yeah, let's have a quick look. So what's this? 500 watts RMS from a tiny little thing. Well, yeah, easy. That'll just be either a integrated Class D chip, or it'll be a discrete components. Maybe the MaxFET package, the tiny little slim plate MOSFETs. I need a board picture really, but yeah, it's very easy to get 500 watts RMS from something that fits in the palm of your hand. That's nothing particularly new or special at the moment. Okay, so let's plug some power wires in and just see exactly what the heck this is doing. I have no idea what this is going to be doing, so we'll have to check it out together and go from there. Okay, so we only have 2 of the output cards here mounted. We have missing MOSFETs over here on this channel. We have missing output cards for these 2 channels. I have loads of these spare. Look how many output cards I've got spare. Ooh, tons and tons of them. So that's fine. Let's just turn the power supply on and see what this wants to do. So power supply FETs here. Do we get any switching on those? Okay, no life at all at first. So remote is here. Remote, we do have remote there. Do we have any lights on here? Where's the lights on this amp? Where's the LEDs on this thing? Are they on the side? Are they on the back? Oh, they're in the middle. Okay, no LEDs. Oh wait, here we go. So we have red and a yellow. We have 9.3 volts, which might be too low for this. Okay, let's increase the voltage to 10.7. Let's see if that is any better. Okay, red and yellow. So it's not happy about something before it even attempts to build any rail voltage. Okay. In that case, let's remove the output drive cards for both of these channels, just in case there is something preventing that from, tripping this into protect, possibly. And in order to do that, we're going to use the massive soldering iron, the 200 watt Weller, to soak up these pins. And I'm also going to preheat the board a little bit with the heat gun. Biggest repairman on YouTube. I wouldn't say that I'm the biggest repairman on YouTube, but thanks for the compliment. Appreciate you, buddy. Thanks for jumping on. Nice and toasty. Let's get these output driver cards out while that's nice and hot. Now this is going to be a bit tricky because I can't really hold it anymore because it's too hot. Actually, there we go. That's fine. Yeah, so I'm going to have to contact them about this. I'm going to have to contact Thermal Master about this because after a while of this being on, you can see that it freezes like every second, okay? Whereas if I just stop and start the video again, now it's fixed. So there's something about having it on for a long time that it doesn't like, so they need to fix that in the software because that's going to drive me nuts. Board is currently at, what's that, 80 degrees Celsius. Nice. I just love being able to see that. It's so cool. Alright, so with both of those output cards removed, will the amplifier let me turn it on now? Was it just a case of something being damaged on the output driver cards that was preventing the MCU from powering up the rails and stuff? Just get rid of any residual solder. Alright, excellent stuff. So, with those removed, let us try again and see whether this will give us any rail voltage or anything like that. Okay, no, we still just have red and yellow. Is it that the power supply, is it that this is trying to generate pulses but it's not? So I'm applying the remote now, okay, now. So we don't get any power supply PWM pulses, which is strange. Usually you get them immediately as soon as you touch the remote. So let's have a look at the power supply board here. Actually, you know what? There's looks like there's some damage on here. It looks like there's a bit of damage on this board. I wonder whether the MCU has actually been damaged a little bit here. Because I can't remember what the heck happened here with this, what we were doing. No idea. Has that been replaced? Did I replace the MCU? Crazy if so. Don't remember doing that. Alright, let's just reflow the MCU pins here, because some of them look a bit suspect, a little bit sus, you know? Yeah, I can't lie, the MCU on here is looking a little bit sus. What I really want to do is remove this to get easier access to it. I do it like this maybe. Actually, that's fine. That's a bit better. Okay. Okay, come on then. Let's do it like this. Fresh solder on the tip. Okay. Sorry if my hat cam gets in the way. I just really need to be able to see this very clearly, you know. And already we have a solder bridge. This is what I didn't want to happen, you see. This is why I put a fuckload of flux. Pain in my asshole. Alright, well let's just drag the solder across the pins, just so that they're definitely soldered, then we can sort out any bridges later. Okay, this is a pain in the ass. Let's use the microscope to have a look and get rid of any solder bridges that we probably just made. Right, so yeah, we're going to need loads of flux because there's a bunch of solder bridges along here. Okay, there we go. It's got rid of that solder bridge there. There's a little last one at the end here. Let's get rid of that. Come on. No more bridge for you. There we go. Okay, that's looking good now. Muy bien. Okay, now the other side. Have to do the same thing. I don't really have enough working area here with this microscope to do this like effectively, so I'm just kind of trying to have to work with what I've got. I need this to go higher to really get a good look on this. Okay, that solved that one. That solved that one, I think. Almost. God damn it! This bridge does not want to come off. Come on. Try and look at it with my eyes instead. Right, that bridge does not want to come off. I need to keep trying. It is the 4th and 5th pins. We'll get there eventually. 1, 2, 3, 4, and 5. Come on. So close. Oh my god. It's possible that they're supposed to be connected on the board, and what I've done is I've just like scratched away at the trace that's linking them. It's possible that they're actually supposed to be linked. You can see that there. But I can't really tell. Very frustrating. Okay, well the pad has now disappeared, so I suspect that was a non-connected one, because it just literally fell off. So that was probably a non-connected part, which is fine. Non-connected leg. As not all of these will be used, so that's fine. Let's check that all the other pins are actually soldered and none of them are loose. I think we're good. Okay, spray, isopropyl. Lowry, yeah, you're a little bit late today, but I'm very early today, so it's fine. Okay, so yeah, given that the MCU didn't look particularly great in terms of how it was soldered, it's either damaged or just due to, you know, how the solder connections that it was making may be damaging it, or maybe it's okay now. So let's turn on the power supply and let's see whether we have anything. No, we still have a yellow and a red light. Oh wait, we have PWM there. Is that supposed to be going to the gate, or is that just some kind of clock signal? I think that's some kind of clock signal there. Is that from the main board, or is that from the card itself? Right, so that's working. But that, yeah, that's 120 kilohertz. So that's not going to be a MOSFET gate drive by any means. So what are you unhappy about now, hey? why you have red and yellow light. Let's grab the thermal imager and let's have a look at the MCU board itself, just to see whether anything is like getting hot on here. Ah, some things are definitely getting warm. Okay, let's put the macro lens on. Let's have a proper look at that. I think I need to change modes back to the back to the smaller mode. Okay, so we've got a resistor there, R3 I think it is. Is it R3? Yeah, R3 gets kind of warm. That is a 222, so that is a 2200. And we have this transistor here, U1. That's a kind of a voltage supply. So that gets warm. Couple of resistors down there. The actual MCU itself is staying absolutely stone cold. So is that being run? Maybe there's a problem with this voltage supply. Man, this new freaking thermal camera is excellent. I would never be able to do this with my old one. Let's just compare how that looks with my old thermal imager. Right, if I wanted to check that with my old thermal imaging camera, this is what it would look like. Well, we are on the next series of Boom or Bust. I'll show you in a minute if you like, if you're patient. Hat cam loading. Is it loading? So this is my old thermal imaging camera, okay? No chance, really, of being able to see any of that. You can just about see a little bit of heat from some random blob, but like, I can't see that. I've no idea what's going on. It's just a mess. So yeah, game changer. So U1, okay, let's probe U1, which is just here. And let us have a look and see if we're getting VCC to the MCU from here. Right, so we've got 12 volts there on its input. Got 12 volts there. Nothing on that one. Let's check these other two pins. Okay, we've got 3.3. So we do have 3.3 volts on the output of that. I assume that's a voltage regulator for the MCU. This resistor that's getting hot, we have 10.10 volts on it. And that drops down to 0. Okay. So we do have 3.3 for the MCU. So the MCU is not happy about something, and it's not giving us any power supply MOSFET pulses. That's frustrating, isn't it? I don't know if I've got any spares of those or anything like that. Very interesting. Okay. Yeah, so it's definitely getting power. That's our remote turn on circuit. Ah, that's a shame. Okay. Could there be something on the main board that is tripping it into protection, like some kind of voltage reference that is shorted. So let's see what voltages we have on the pins to this board here. So obviously we've got ground, we have our remote voltage, we have nothing there, nothing there, nothing there. We have signal there. This one right here. This one looks like, oh, we've got a bit of voltage there. 2.9 volts on this pin, whatever that is. Okay. Nothing on there. We've got 1.1 volts on this pin, which then disappears immediately. 12 volts on that pin. That's the remote. Okay, so I'm not really seeing any voltages from the main board, I don't think, that might be causing this to trip into protect. Let's probe the pads of the output driver cards here, just to see whether we get any of those voltages over here, to see whether it's coming, the protection signal is coming from the output circuit perhaps. Ah, we've got clock signal to the output driver card. That's interesting. That's pretty cool. So it obviously synchronizes all of these with an external clock. That's pretty cool. Okay, let's have a look on the main board. TL072s. They don't have any supply voltage, so they're not going to be influencing anything. Ah, I've actually just noticed I'm missing a power supply driver over this side. I've obviously removed that at some point. Is that the only power supply driver? I think it might be. So I've removed that at some point. I didn't even notice. But it doesn't even actually look like we're getting any pulses being sent to it from the MCU anyway. What have we got? We've got 2 volts there. That's really strange. Maybe let's try fitting a driver in there, but I'm not getting any pulses being sent there, so we're just getting a little bit of DC. See here on this pad here, we're just getting like 2.9 volts DC sent there, which is on one of the inputs, and on the other one we've got nothing. So that kind of suggests to me that the MCU might be damaged. But nonetheless, let's put a driver on this pad in here anyway, just to see what happens, I guess. I'm just finding a single MOSFET driver. On these ones, you can use a 4427 or any compatible alternative. So let's find a 4427 or something. There we go, 4427. Let's drop one of those on, just because we can. Excellent. Okay, so going by what the oscilloscope was showing a minute ago, it seems that we're just going to get a bit of DC being sent to the driver, which is probably going to spike current to the power supply FETs here. So let's just see whether that is actually the case, or whether we actually get any switching, any PWM on this. No, it just yeah, it just basically spikes DC to the power supply gate. So there's definitely something wrong with the MCU. Is the MCU even fitted the right way round? Who knows? Right, what I'm going to do is I'm going to remove this card, because there's definitely like stuff is not going correctly with this card. So I'm going to remove this card entirely, and I'm going to see what's going on with the MCU on there, if anything. And I may need to just preheat the board a bit here, because this has quite a high thermal mass. Have you ever used a heat gun to remove these driver cards? Yes, I have. I think I've used a heat gun in the past to remove driver cards and stuff. Yeah, it does work well if you can get the thing hot enough and stuff. But since I've got the big soldering iron, I might as well just use that. Ow, ow, ow! That's very, very hot. Very, very hot. That's very, very hot. That's very hot. Okay, so the power supply PWM card is out. So let's just have a look at this under the microscope just to see what its condition is like up close. I'm a bit suspect of it. Right. What are you saying here, my friend? Okay, so we've got a resistor there, R10 is missing. I don't know if that was fitted from factory or whether I've removed that at some point. D1 is missing again. I don't know whether that was removed from factory or whether that's normal. I wanted to check the orientation of the MCU. Is that even in the right way round? That would be hilarious if it's backwards, wouldn't it? Let's just have a look. Let's get the thermal, heat gun on. I'm going to remove the MCU actually entirely. Okay. No, so that was in the correct way round. Okay. That pad that we removed earlier by accident, that doesn't go anywhere. It looks like the R10 actually possibly is required here. I don't know what the heck that would have been. I don't think I've got a board here to take reference from. Perhaps what I can do actually is this will probably be a very similar setup to the Banda Viking 7K in terms of the MCU. So maybe I can have a look at the layout of the MCU on the Banda Viking 7K just to see whether it's kind of similar and what resistors we're missing and what ones we need. But yeah, that's going to be in the loft, so maybe we can look at that another day. So yeah, guys, it's been a pretty fun stream. 2 hours 27, not too bad. Nice little afternoon stream. I'm going to lock off the stream just now, get some dinner, and enjoy the rest of my evening. Stuff that is coming, Boom or Bust, which is just behind me. If I just remove my hat cam for a minute. Let's just show you what's going on with Boom or Bust. So I have the PT Cruiser. I've been making some modifications to the boot floor so that it mimics the life-size vehicle correctly. So we've got the Dremel there, I've been doing some modifications, so that's on its way, that's in the pipeline. I'm working on that in the background. And yeah, just kind of always busy. But thanks for sticking with me today, guys. Fun little stream. Nice to get back streaming. Yeah, check out the thermal camera. I'm going to message them about a couple of the issues we noticed today. But yeah, have a great rest of the day, and I'll see you a bit later on.